In this class, now I am going to explain you how to solve a rational polynomial inequation. So for that we use this method called Wavey curve method. Okay, right. See here, you know what is a rational polynomial inequation. See here, a rational polynomial expression will be in this form f by g, where f it may have with variable x or y any other variable. Okay, so here f and g, if the two expressions in the form of p by q, then that is known as a rational expression. If it contains polynomials, then that is called as a rational polynomial. Inequation means along with this it will have either greater than 0 or greater than or equal to 0, less than 0, less than or equal to 0. If this rational polynomial expression contains any one of this inequality symbol, then that is known as rational polynomial inequation. Okay, now let us see how to solve that rational polynomial inequation. So I am going to explain you this by taking some examples. Now see here, let us take x square minus 5x plus 6 by x minus 1 greater than 0, or it may have greater than or equal to 0, less than 0, less than or equal to 0. How do we solve this rational polynomial inequation? Let us see. The first step, so here numerator and denominator we have to express as product of linear factors. In the denominator already linear factor is there, but in the numerator quadratic expression is given. Now express the numerator as product of linear factors. So you will get x minus 2 into x minus 3 by x minus 1 greater than 0. And hereafter, so observe the coefficient of x. If it is positive, it is okay. If not positive, make sure that coefficient of x is positive. Okay, in all these three, coefficient of x is positive. Okay, so now in the next step, okay, observe the denominator. So whether it is positive or negative, how do we say? We cannot say. Okay, if the exponent is having even exponent, you can say this is positive, but here it is having nothing is given, means here 1. So it is having odd exponent, means we cannot confirm the sign of this denominator, whether it is positive or negative, we don't know. So that you have to make the power of the denominator as even. How we can make? By multiplying numerator and denominator with 1 x minus 1. So that here you can make x minus 1 whole square. Now it is positive. Okay, in the next step, what you have to see? After making the coefficient of x as positive, observe the denominator. So whose power must contain an even positive integer. So now we made here positive. How? By multiplying numerator and denominator with x minus 1. So that here we have got x minus 1 whole square. In the next step, so multiply both sides with this denominator after making even. Here x minus 1 whole square, here x minus 1 whole square. And this one cancelled. 0 into something 0. In the next step, x minus 1 into x minus 2 into x minus 3, which is equal to 0. Okay, right. Now identify the critical values of these three linear factors. Critical values means which will obtain by equating these three linear factors is equal to 0. Okay, in the polynomial chapter we call them as zeros of the polynomial. For which value of x it is going to be 0? 1. And this one 2, this one 3. These are called critical values. So in the next step, go to the number line. So whichever, here it is positive infinity, here it is negative infinity. So whichever critical values are generated from here, so which must be written on this number line in the ascending order. Here 1, 2, 3. 1, 2, 3. By these three critical values, we divided that number line into 4 intervals. See, one is more than 3, one is 2, 2, 3, one is 1, 2, 3, 1, 2, 2, and one is smaller than 1. So now hereafter take a curve like this, transverse wave. in the sound lesson you might have learnt in the physics. Transverse wave which travels like a crested trough. Okay, so now hereafter, see, this is the given a rational inequation. Right, students, now take any value more than 3, like 4, substitute over here. So numerator will become positive, denominator will become positive. Am I right? Hence positive by positive, positive. So that not only 4, if you take any value more than 3, so this will be positive. We want positive only, no, more than 0, so that all will comes under our solution set. If you take any value 2 to 3, this will be negative. We don't want that. If you want to take any value like 2.5 right here, this is positive, this is negative, this is positive. Minus into plus, minus, minus by plus, minus will come, so that it will not come into our required solution. So if you take any value from 1 to 2, this is going to be positive. And if you take any value from 1 below, this will be negative. So here, plus, you start from right, plus minus, plus minus. We want greater than 0 means we want this result should be positive, no? Where we got positive? From 1 to 2 and 3 to infinity. Now write the solution set. Write here open interval of 1 to 2 union 3 to infinity. You know the meaning of this brackets. Close interval of a comma b means, so it represents the values lying between a and b, and in which extreme values a and b also included. So you know the meaning of this open interval of a comma b means it represents values lying between a and b. This a and b extreme values should not be included. So you know the meaning of left side open, left side closed, right side open. It represents the value lying between a and b, and a included into the interval. And left side open, right side closed. Same, it represents the values lying between a and b, b is included. So here we have tried here only having greater than, no, right to open. So this is our required solution set for this given inequation. Suppose if it is having greater than or equal to 0. Now what is the solution set means? Here you have to write close intervals 1 to 2 union 3 to infinity. After writing the solution set, so here having way here infinity minus infinity, at that place you have to write open symbol, because exact value you don't know, no? So that here we write open. So here after writing the solution set, observe the denominator. What is the critical value of denominator? 1. So here it is having 1, no, in the solution set, so that it is not write our solution. So it should not contain 1. So that write here open symbol, because if it includes 1, if you write here 1 minus 1 0, something by 0 not defined, no? So that after writing the solution set, make sure that the solution set doesn't contain the critical values of the denominator. It may have critical values of numerator, because greater than or equal to symbol, no? If it is having 3 minus 3 0, 0 by something 0, 0 is greater than or equal to 0, means it is included. Okay, the students. So after writing the solution set, so take care of it's this solution set doesn't contain the critical values of the denominator. It may have critical values of numerator. Okay, this is a solution set for that inequation. If it is having less than 0, so what is the solution set for this? Where it is negative, x belongs to, see, smaller than 1 means where do you reach? Minus infinity to 1, right to open, union 2 to 3. This will be the solution set for that. If it is having less than or equal to symbol, so here what you have to write? Close interval of 1 to 2 union 3 to infinity. And whenever it is having greater than or equal to symbol and a less than or equal to symbol, so after writing the solution set, check whether it is having the critical values of denominator or not. So what is the critical values of denominator? 1 having, so that this is not right solution. So that here it has to be removed. How do you remove? By writing open interval. Okay, right. Now let us go to one more application. Right. Observe this. X minus 3 into 2 minus x by x square minus 5x greater than 0. So already numerator is factorized. Denominator not factorized. Factorize it. X minus 3. Okay. 2 minus x. Now take x common. X minus 5 greater than symbol. Next step. Observe the coefficient of x. Here it is positive, positive, positive. But here it is negative. Make it positive. How do you make positive? Take minus common from this. Write that minus here. X minus 3. X minus 2 by x into x minus 5 greater than 0. Now multiply both sides with minus. So you know here minus 3 greater than minus 5. When you multiply both sides with minus, inequality sign will change. So that when you multiply both sides with, it will affect on the symbol of inequality. Greater than will change as less than. So here x minus 3 and x minus 2 by x of x minus 5 less than 0. Okay students, hereafter go for writing that solution set of that given inequation. What did I say in the previous one? All the coefficients of x are positive. Now make the power of the denominators as even. Here having exponent, one exponent, here 1. 1 means odd, no? If it is even, you have to leave like that only. If it is odd, compulsory make sure that exponent must be even. How do you make even, amma? See here, x minus 2 into x minus 3 in the numerator by x square x minus 5 whole square. So for that what I have done, I have multiplied numerator and denominator with x minus 5, x minus 5. So that here we got square less than 0. Hereafter you have to multiply this with left side of the equal less than symbol, right side of the equal symbol. So that you can eliminate this one. Right side 0 into something 0. Same like previous one. So after that what is left? X into x minus 5, x minus 2, x minus 3 less than 0. Here don't get confusion. Multiply this one with left side and right side. So left side one and this one cancelled. Right side one 0 is something 0. This will be left. Now go to the writing critical values for this. So here x is there. What is the critical value of x? X minus 0, no. For which value of x it is going to be 0? 0 only. So that the critical value of this one is 0. And this one 5. And this one 2. This one 3. Now hereafter go to the number line and represent them on the number line. So write okay, all these critical values in ascending order. Sometimes here you may get negative rational numbers, or sometimes here you may get irrational numbers also for these critical values. So here represent them in the ascending order. So 0, next 2, next 3, next 5. Only this critical values only must be represented on the number line. Don't write other real number. Okay students, hereafter what you people have to do? Okay, you have to take the curve like this. I said to you in the previous one. Now write here plus, minus, plus, minus, plus. Now here we want less than 0. Actually in the given one having greater than 0, but we made okay, the coefficient of x is positive in one linear factor, so that we got less than 0. We have to write the solution set for this. That will be the solution set for the given one. Okay, here having less than 0. Less than 0 means where it is negative here, x belongs to, when x is 0 to 2, that expression will be negative. If you want to take any value between this and substitute here and check. Union 3 to 5. This is our required solution for this. Okay, so you know if it is having less than or equal to symbol, so you have to write here close intervals, but after that you have to check the critical values of denominator. Here what are the critical values of denominator? 1 and 5, but here 1 is included. here 0. Critical value of this one is 0 and here 5. 0 and 5 are included. Here 0 included, 5 included. So that here you have to write open, here you have to write open. Open means this 0 and 5 are not included. If it includes, this becomes 0, something by 0 not defined case will arise. Hence, here you have to write open brackets. Similarly, if it is having suppose greater than 0, you know, you have to take positive intervals. X belongs to, so minus infinity to 0, this side open, union 2 to 3, union 5 to infinity. So similarly, can you write the solution set if it is having greater than or equal to 0? You can. Okay. Now observe one more problem. See here. X plus 1 whole power 99. X minus 2 whole power 102. And x plus 3 by. So x power, okay, 28. And x plus 4 whole power 19. Can you solve this? What? Okay, already numerator and denominator is expressed as a product of linear factors. So now in the next step, what you people have to do? Make sure that coefficient of x is positive. In all, it contains coefficient of x is positive. So that don't go for any changes. And hereafter, what you have to do? Denominator. Okay, so observe the exponent of the denominator linear factors. Here it is having even, no problem, but here it is having odd. So okay, this one we have to make as even. How? Multiply numerator and denominator with 1x plus 4, so that here we will get 20. Hereafter you have to multiply this one with numerator and means left here and here. Okay, multiply this expression with the left side of this greater than symbol and right side of this. So your right side 0 into something which becomes 0, and this one will be going to cancel. What is left after that? This will be left. This will be left. Okay, right. Now for this, okay, so observe the 4 linear factors. So here this one and this one and this one are having odd exponents, and this one is having even exponent. So if whichever linear factor is having even exponent, whose critical value must not be considered while writing the critical values. Okay, so whichever linear factors are having odd exponents, whose critical values only must be considered. Here whose critical value is minus 4. Whose critical value minus 1, whose critical value minus 3. Don't write here critical values of linear factor having even exponent. Okay, hereafter go to the number line and represent them on the number line in ascending order. So smallest one is minus 4, next minus 3, next minus 1. Now having greater than or equal to greater than symbol, no? Now write the solution set. Okay, sorry, go to the number line and sir, already we have represented now here. Alright, now write the wave. So we want a greater than means here plus to minus. After presenting this sign, now write the solution set. X belongs to open interval of. So we want positive. Positive means where it is positive? Minus 4 to minus 3. In this interval, that Wavey is telling us positive. And here, where it is positive again, more than minus 1. Union, right here union. So minus 1 to infinity. In this interval, if you take any x value and substitute in the given expression, so that will be true for that x value. Hence, this will be our required solution set for the given rational polynomial inequation. So suppose if it is having greater than or equal to symbol, less than 0, less than or equal to 0, you know how to write solution set for all these inequations having this kind of inequalities. We have learned one application before this. Same procedure must be applied to this one also to write the solution set for rest of them. Okay, thank you.